Hello Year 11 and welcome to our second video here for our fifth topic. We're looking at reflections in the X and Y axes today. Okay, so in our previous exercise we were translating functions, translating up and down, side to side, and this time reflections, X and Y axis, we're going to flip them side to side, up and down. Okay, we're going to flip them over. A reflection as though in a mirror. So let's see how that looks. If we wish to reflect a function in the y-axis, read this carefully, listen carefully. If we wish to reflect a function in the y-axis, we replace x with negative x. Okay? Replace x with negative x to reflect in the y-axis. And here we go. To reflect a function in the x-axis, replace function x with negative function x. So, if I take the negative of the function, I will reflect it in the x-axis. If I replace x with a negative x, I will reflect it in the y-axis. Okay. We'll keep moving on here, and we have a couple of examples. So, what about this equation here, y equals 2 to the x? That is, of course, an exponential function, and the base is greater than 1, so it represents exponential growth. It'll have a y-intercept of 1, an asymptote of the x-axis when x is very negative. Now, if we reflect it about the y-axis, remember what we do to reflect it about the y-axis? I replace x with a negative x. Let's see how that looks. I think it's going to look like this. There we go. So, here we go. Y equals 2 to the negative x, right? Replace x with the negative x. That reflects it in the y-axis. Now, using some index laws, you could think of that as 2 to the negative 1 to the power of x. Right, because index laws, power of a power, we multiply those exponents together. And 2 to the negative 1 is 1 over 2 is a half. So that's equivalent to y equals 0.5 or a half to the power of x, which is again an exponential, but this time because the base is between 0 and 1, this represents exponential decay and is a reflection of the function y equals 2x about the y-axis. We have another function, or another transformation we're going to make. Remember, these are all transformations. About the x-axis, and what I do is, I take the negative of the function, right? So I just whack a negative sign, whack brackets around the whole lot, negative sign out the front, and that's it for this one. So there we go. They're the equations of the two functions, reflected in the y-axis, reflected in the x-axis. And what do those sketches look like? Well, let's get my head out of the road. Let's tuck it up here. I think that'll do it. Here we go. Drum roll. There it is. Oh no, my head's still right. Story of my life, really. No, look, I can go here. That'll work. So, here we go. I have blue is my original basic function of y equals 2 to the power of x. Sorry, it's chopped off some of these little things a bit. The blue line here is y equals 2 to the power of x. Now, we reflected that about the y-axis, and I get this green function. Okay, so you can see it's sort of like a mirror image about if the mirror were placed on the y-axis. And this green function is the reflection in the y-axis, y equals 0.5 to the x. Okay, that's the green one compared to the blue one. Purple one here certainly shares much in common with the blue line there, the blue graph. It has been reflected about the x-axis. Okay, and that's y equals negative, brackets, 2 to the power of x. Rightio, that's reflections. Let's try this down here. Here we go, reflect on that. So, that's it. If you have any questions, you know what to do. A reminder of what we learned here: to reflect in the y-axis, replace x with negative x. To reflect about the x-axis, replace function x with a negative function x. Okay, thanks very much, Year 11. See you next time.